This is exercise 3J, which is tables and rules, and is covered on page 162 of your textbook. Great. So we've talked about rules and what rules are when it comes to number patterns and spatial patterns. Rules tell us, well, how two things are related. So in other words, it's the relation between two varying quantities. For example, if I have, we talked about last video we talked about if I had, let's say, if I had matchsticks to make up triangles, well, depending on how many triangles I have, it's going to have that many matchsticks, right? So that's a rule. That's how we calculate or predict different quantities. So, for example, if my output being what I get, my output is the input plus 3, it's a rule that connects the input and the output. So say, for example, my input is 6. If my input is 6, that's what I'm putting in, right? If input is 6, 6 plus 3 gives me 9, and my output is 9. That's how that works. So that's what output and input is. The set of input values is called the domain. So input is domain, and the output is the range. Now, these are just terms we're going to be using throughout the next couple of weeks. So don't stress if it doesn't really make sense right now. We'll be using them in the future. Okay. So these over here. They're what we call tables of values. They're called tables of values because they nicely and neatly put the values there so that we can actually see those in a nice, neat table. So this first example over here tells us to find the rule for each of these tables of values. So I look at this and I'm saying, how do I get from 3 to 12? Well, I could, let's say, I could times it by 4, I could plus 9, I could do whatever it is, right? I could times it by 5 minus 3 or whatever. We can do whatever we want. But this rule has to apply to all of the input numbers. So how do I get from 4 to 13? That's another question, right? Because if I say, well, it's just times by 4, 4 times 4 is actually 16, but this is not 16, it's actually 13, right? So it's not times by 4. We need to find a rule that we can put in and actually be able to find how I can calculate the output from here. And by looking at this, I know that this goes up by 1. Oops, sorry. I know that this goes up by 1 every time. Plus 1, plus 1, plus 1, etc., right? And the bottom, you can see, also goes up by plus 1, right? Oops, that's a 1. Plus 1 here. So they all go up by plus 1, which means that I think I'm looking at an addition or a common difference. A common difference, just a reminder, a common difference. Oops. Whatever, we'll leave it at that. Common difference is an increasing or decreasing amount that's constant. So this looks like to me a common difference. So how do I get from 3 to 9? I plus 9. Plus 9. Sorry, how do I get from 3 to 12? Plus 9. How do I get from 4 to 13? Plus 9. 5 to 14 plus 9, you get the idea. And it applies to all the inputs to outputs. So I can say that my output is equal to my input plus how much? Plus 9. Because that's what we said, right? So if I said 7 here, let's try it over here. My input, which is 7, plus the 9 gives me 16. That's correct. So that's my rule over here. My rule is output equals to input plus 9. Okay, let's move on. So this one on the right, I'm going 1, 2, 3, 4, 5. But 1 goes to 7, 2 goes to 14, 3 goes to 21. It's quite clear. You guys can see. I think you guys know your times tables, right? So 1 to 7, it's a times by 7. 2 to 14 is times by 7. 3 times 7 is 21. 4 times 7 is 28. You get the idea. So I can say that my rule is my output is actually equal to my input times by 7. And you can write this instead as 7 times input. That's up to you. Equals 7 times input. Alright, so that's the idea. Or I could write all input times 7. exactly the same thing. So that's the idea. I can now go ahead and try and predict the next value. So if I had, let's say 111, 111, I know that my output is going to be 777 because I'm just timesing it by 7. So that's what the rule is for. Let's keep going. So my table of values can be created from any given rule. So any of the rules that we've got. Now let's start with the first input number and use the rule to calculate the corresponding output numbers. So it says here, that's my rule over here. That's my rule. It says my output is just my input take away 2. So my input is 3 here. Over here is 3. 3 take away 2 is 1. Bam, that's it. 5 take away 2, 3. Oops. 3. 7 take away 2 is 5. 12 take away 2 is 10. 20 take away 2 is 18. Alright, let's do this one over here. It says my output over here is 3 times my input and then plus 1. Remember my brackets first, right? So our BODMAS, remember that. So 3 times my input and then plus 1. So let's do this one over here. My input is 4, so 3 times 4 plus 1. 3 times 4 is 12. Plus 1 is equal to 13. So I would write 13 right here. 3 times 2 for this one over here. 3 times 2, because my input is 2. 3 times 2 plus 1 equals to, what's 3 times 2? It's 6, right? So 6 plus 1 gives me 7. So I write 7 there. And you get the idea. So this one over here, well, 3 times my input, which is 9, plus the 1, gets me an answer of 28. And then this one would be 37, and this one would be 1. This one is 1 because it's 3 times my input, which is 0, plus 1. 3 times 0 is 0, so 0 plus 1 gives me 1. Alright, so that's how we do something like that. Let's finish by going through some this kind of table. So this table over here, we've got question marks over here, and let's try and fill those numbers in. But first we have to find the rule for each one. Over here, well, what's the rule? It's going 2 to 6, 5 to 9, 6 to 10, and you can see quite clearly it's a common difference. Plus 4, plus 4, plus 4. So the rule is that the output, my output is equal to my input plus 4. So that means that 1 plus 4 gives me 5, so that's a 5. 8 plus 4 gives me 12, and that's a 12. Great. Let's do this one in the middle. 12 to 36, 5 to 15, 8 to 24. That's clearly a times 3. So I know that my rule is that my output is equal to, oops, it's a bit curved, is equal to my 3 times my input, or input times 3. You can choose whichever one you prefer. So 0 times 3 gives me, well, 0. And 23 times 3 gives me 69. And that's how we solve that. Alright, last one on the page. So how do we get from 2 to 3? And then how do I get from 3 to 5? 9 to 17? This is actually quite a more difficult one. Yeah. So it's not a plus 1, because if it was plus 1 over here to get from 2 to 3, it'd have to be a plus 1 here, and that doesn't really make sense. What I gather is that it's actually times 2 and then minus 1. 2 times 2 minus 1. So 2 times 2 is 4. 4 minus 1 equals to 3. Let's go this one over here. So that's this one here. Let's do this one here. 2 times 3 minus 1. So 2 times 3 is 6. Minus 1 is 5. It's 5 there. Let's try this one over here. 2 times 9 minus 1. 2 times 9 is 18. Take away 1 is 17. So that's how we do it. Our rule is that our output, our output is equal to 2 times our input, and then we take away 1. So 7, let's do this one over here. 2 times our input, which is 7, take away 1. So 2 times 7 is 14. Take away 1 is 13. So that's 13 here. Over here, 2 times my input, which is 12. take away 1 gives me 24 minus 1, which is 23. And that's 23. All right, hopefully that makes a bit of sense. Best of luck.